Hello Q-steppers and fellow R coders, and welcome to another tutorial in the series of How to in R. This tutorial will cover how to conduct a multiple linear regression in R. The following tutorial will cover how to interpret those results, and then part 3 will cover the assumptions of multiple linear regression. So what is multiple linear regression? Multiple linear regression is an extension of bivariate linear regression. In multiple regression, we have 2 or more predictor variables. So we have our numerical outcome variable, and we use 2 or more predictor variables of any level of measurement to explain the relationship with our outcome variable. In simplistic terms, we are analysing the value of the outcome variable based on the values of our predictor variables. So how does it work? When we compute a multiple linear regression, the model calculates the line of best fit. This line of best fit minimises the variances of each predictor variable as it relates to the outcome variable. Now again, we will use the most recent publication of the Scottish Index of Multiple Deprivation, released in 2020. Now I have created a smaller subset of the variables of interest. This is just for viewing purposes and it's not mandatory. Okay, so let's just run that code. In our model, we will use the alcohol variable as the outcome variable. So this is a standardised ratio of alcohol-related hospital stays, where the standardised ratio value of 100 is a Scottish average for a population of the same age and gender profile. If a data zone holds a value of under 100, then they are under the national average. Simultaneously, if a data zone holds a value over 100, then they are over the national average. So to compute a multiple linear regression in R, we need to make sure that our variables are correctly classed. As you may have seen in previous tutorials, R can sometimes import the data as the wrong class. So we can quickly use the class function to check out the variable. We can quickly check the class using the class function and then place the variable in the brackets. So this is already classed as numeric, which is good. Let's have a look at the summary of the alcohol variable. Looking at the minimum value of 0, this means that there are at least one data zone that has 0 instances of alcohol-related hospital stays, where we have a data zone with a standardised ratio of 917. Now remember, you can view the data by, you can check out which intermediate zone or which council area hold these values by using the arrow at the top of the data set. So let's quickly check the class of the predictor variables. They're all numeric. The urban variable should be classed as a factor, as this is a nominal variable that categorises a data zone by urban or rural, coded 1 for urban and 2 for rural. So what we want to do here is we want to create a dummy variable. This has already been covered in the How to Clean Data tutorial, but I will quickly go over the code here. So we load the car package, so we can use the recode function. So we want to change the code, which is 2 to 0, and keep 1 urban as 1. Okay, so if we run that code, okay, and then we now need to change it to a factor variable. This means that when we enter this variable into our multiple regression model, we shall find the slope for the higher value, which in this case is urban data zones. This will mean that we can make inferences if urban data zones have a higher or lower prevalence of alcohol-related hospital stays when we run that model. So now if we check the class in the table function, we now have a factor class variable. We have 1,201 rural data zones, while we have 5,775 urban data zones. Before we run linear regression, we need to remove any missing values from the outcome variable. So we need to create a new subset of data to analyse. So we name the new data, we use the subset function, we call up the data we are subsetting from, we then use the exclamation mark as .NA, and then we place the outcome variable in the brackets. So remember, you should use this new located data going forward. So let's run that code. Okay, so we're now ready to compute our multiple linear regression in R. So we name our model. Remember, names are arbitrary. This is just for the global environment. We then call up the LM function, which is short for linear model. We then place our outcome variable followed by the tilde sign, so this sign here. Then we add our predictor variables. After each predictor variable, we must use the plus sign to add more predictors. Okay, so we add in all of our predictors. And then lastly, we name the data. So just as a reminder, we are analysing how alcohol-related hospital stays are forecast by our predictor variables. Our first predictor was the depressed variable, which is the percentage of people prescribed mental health medication. Our second predictor was the dummy urban variable, which is analysing the effect on urban data zones over rural data zones. Our third variable is the attainment variable, which is a score based on school leavers' highest level of qualification. And lastly, predictor 4 is the income rate variable, which is the percentage of people who receive welfare benefits as they are not working and are therefore income deprived. So if we run this code, nothing really happens. You will see the model appear in the global environment. To view those results, we use the summary function and use our model name that we have created above in the brackets. So if we run that code that looks like it's already been ran, you get your summary output of your multiple linear regression. Hopefully this tutorial has got you familiar with how to compute a multiple linear regression in R. The next tutorial, part 2, will cover the model evaluation and how to interpret those results. So happy coding, Q-steppers, and remember to subscribe to our social media channels, and thank you for watching.